second. Okay. All right. So what you guys saw, of course, what I shot you guys out in the Slack is, of course, we're not going to layer 3 until we master layer 2, right? And of course, our last session we were talking about one of the three basic functions or major functions of the switch, which was learning and forwarding frames, right? One of the next, major functions I want to touch on, and Aaron, I know me and you have touched on this before, and I know you're starting to get make it second nature, is making sure that in a topology that we have redundancy, that we have a loop-free topology, right? And in that sense, we use spanning tree. Okay.
Yes.
So
yes.
we're going to go ahead and probably, I want to scale this out to probably 3 sessions. We're not going to make it. I'm going to try to, God willing, not going to try to make it difficult, hard. I want you guys to understand it. CCNA level, from my experience, versus a CCNP level, it's real basic, but you guys really need to know, just because they may ask you questions in a certain type of way. So I want to go ahead and see if I can explain it as easily as possible, so that when you guys are going back and reading, when you're at Starbucks or studying on your own, you guys are like, all right, makes sense because we said it in a certain way, right?
Appreciate that.
So
appreciate that.
Thank you.
It's all good. It's all good. It's all good, guys. All right. So first thing first, what the hell is a loop, right? What is a loop, right? If we think about, me, Nick, and Aaron, we're in Madrid, right? And
Yes.
let's say we need to go ahead and get to downtown, right? But we need to go around one of those circle loops, right? And so what if, right, to get to the next street, right? We enter in a loop, we get to the next street, and that street suddenly closes off, right? And then the street that we entered suddenly closed off, right? Us in that little rental car, what's going to happen? We're going to keep going in a circle and circle and circle and circle. And what does that mean? We're going inside a continuous loop of, the car just going, round and round and round and round. Does that make sense?
Yes.
Yeah. Oh, yeah.
Right? But we don't want that, right? Because we got to get downtown, right? The party starts at 8. We don't need to keep going in circles. I think I'm going to get crazy. If you think Aaron gets crazy, I think I'm going to get crazy. Going in a circle, right? So, and Nick, I know you'll probably get crazy. So, we have, and going back to speak about the spanning tree, right? We want to make sure that there is a way to where, we're not creating loops, and that, we have redundancy, but at the same time, we have one way of where traffic can flow. That's the whole goal, right? We have redundancy, but there's only one flow of traffic. There's no 2 possible flows, and to the point to where we're going round and round and round and round, okay? So in this topology, and again, we're not going to touch the CLI. You guys know how I am. Aaron, you know how I am. We're not going to touch the CLI just yet. We're going to just touch on theory, okay? So let me take my handy dandy. Oh, man, I feel like the guy from Blue's Clues. Let me take out my handy dandy pen and piece of paper.
You've been hanging out with kids.
Hey, leave me alone. I'm an uncle now. But where is my pen? I should have a pencil. Where is my pencil? Oh, there we go. Oh, ooh, there's your pencil. That's me. All right. What I have? Perfect. Okay. All right. So in this topology, right, we have switch 1 and we have switch 2, right? Let's imagine, right, to make it make more sense. I know you guys already work in tech, right? Let's say we have, Nick and Aaron, you guys are the 2 network administrators. You guys are in charge of one floor, right? And we have, floor is like 7,000 square feet, right? And we have some cubicles, right? So we have, 2 switches in place, right? We already planned the topology well. We have roughly 96 ports, right, for our users, right? 48 port switches each and 96 ports in total. So we go ahead and we have that in there, right? But between the switches, right, we only have one link, right? And so one of the switches, they have a fiber link downstairs, right, to the actual IDF for that building, right? And so what does that mean? This is the only way, if Aaron and Nick's end users that they take care of on that floor, that's the only way that they get out to the internet and start going on Google or YouTube or Twitter, et cetera, right? So we need to make sure that there's only one flow coming from the end users going through the switch to get out to the internet. Does that make sense? You still with me?
Yep.
Right? But let's talk about this, right? So we have this one link. I'll say it again. We have this one link. What happens if between these switches the links go down?
Communication.
We're not communication, right? We're not going to have communication out to the world, right?
Correct.
Maybe one side of the floor, right, is not going to have communication to the world because maybe there's, maybe the uplink is only connected to one of the switches, right? We're going to say it's connected to Aaron's switch, which is switch 1, and Nick, your switch, which is switch 2. Now your people doesn't have any connectivity, and so now we're trying to figure out what's going on, right? And so we can't have that. We need to make sure that it's fixed, it's resolved, everything's working, et cetera, et cetera. So what did we do, right? What did they create back in the day? They said, hey, go ahead and plug up another cable, between your switches, back in the day. We're going to go ahead and create some redundancy, right? So you don't have, which the key word that, Aaron, you'll probably see in your Network Plus and your CCNA is we don't have a single point of failure. Right.
Yes.
And so,
yes.
and so the way to do that, of course, is simple. You just go ahead and plug up. Hold on, let me fix that. We just go ahead and plug up another cable between the switches. Right. Perfect. Mm-hmm. We have redundancy.
I have a question.
Right?
I have a question.
Yeah. Oh yeah, sure.
Would it be sufficient to run a situation like APPIA, where you have something, but pardon?
You're talking about a PIPA address?
Yes, where you have a situation where it can't find a DHCP, and then it grabs this other thing, and it just like roams around until where you could have a situation with a DNS, where it can reach out to the internet, if it wants to reach out to the internet somehow. Am I headed in the right direction with this?
You're headed in the right direction, and guess the hell what? We're going to use that example, right? So hold on to that example in a second, okay? Let's finish talking about, the spanning tree flow, what have you, and how it's going to work, right? So,
yes.
But Aaron, yes, hang on to that example. So we just added, right? So we didn't want, you guys, right, didn't want a single point of failure. You and Nick said, cool, let's add another link. They have this technology called spanning tree that's going to prevent loops, right? But before we even think about preventing loops, we have to understand the why, right? So we plugged up another cable, right? We don't have a single point of failure. Let's say we didn't have spanning tree, right? Let's say, right, we have Aaron has an end user PC that just plugged up into port 2 on switch 1, right? And, it's not able to, it's not so much not able to find a DHCP address, right? It can't get out. Why? Because here's what's happening. Let me get my little pencil. And let's use a different color. All right. So we have Aaron's end user PC, right? And so Aaron is trying to get to the DHCP server, right? DHCP server is in another building, right? And so we want to make sure we hit one of the goals that we try to hit the goals that spanning tree is trying to achieve, which is we have one way flow of traffic. We don't have redundant flows to where it's creating a loop, right? And so if Aaron PCs go ahead and send that DHCP packet, right? That DHCP discover, right? It's going to go ahead and send the broadcast, right? So what does that mean? I think we all know what a broadcast is, but if not, I'll go ahead and explain it. Broadcast, whenever a switch receives a broadcast, it's going to treat it like an unknown unicast frame. What does that mean? The switch is going to go ahead and say, hey, I don't know where the destination is. It doesn't live on my MAC address table. And of course it wouldn't, because of course it's going to be all S. So if it doesn't live on my MAC address table, the switch says, hey, I need to go ahead and blast this out of all of my ports and say, is anybody out there, right, for this for this IP address in this location, right? And so it's going to go ahead and blast it all out here, right? It's going to send, right, the broadcast out to everybody, right? And so we have the two redundant links, right? Still, you guys still with me? We still have the two redundant links, but we don't have spanning tree yet.
Oh,
right? Spanning tree doesn't exist, right? And so from Aaron's switch that he manages, switch one, it's sending that broadcast. He's trying to get downstairs to get to the other building to get to the DHCP server. But Nick, your switch has two different links. That DHCP discover is being sent down both links. So it says, oh, okay, I'm going to go ahead and, oh, I see where this is trying to go. I'm going to send it back this way, right?
Yeah.
I'm going to send it back this way, right? I'm going to send it back this way, right? And so, because again, I have two redundant links, two links, right? And so I'm shooting it out all my ports. The switch is doing, knowing what it's doing. It's going to leave the building. That's the lead. It's going to leave the building, but it's also, but that broadcast is still going to be sent to switch two, because switch two is going to fulfill its duty, which is whenever it receives a frame that it does not know, unknown unicast frame, it's going to broadcast it out of all ports.
Mm-hmm.
So then switch two is going to receive it. It's going to broadcast it out of all of its ports, one going to the uplink and the other two going to the links to Aaron switch. And so Aaron switch is going to receive it, right? And so after Aaron switch receives it, Aaron says, oh, I have a broadcast message. Boom, 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 boom. And so back to Nick's switch. Nick's switch is going to go ahead and receive it again. And I think you guys know where I'm going, right? And it looks like my niece, is drawing on the wall. It really looks that, right? And so, you know, she would probably get in trouble. Well, I mean, not with me. I mean, she's too damn sweet, right? But you guys get the concept, right?
Yes, sir.
Hey,
you guys get the concept?
David. So let me ask you. Sorry. So I just came in, David. My fault. What's going on, y'all?
It's all good. It's all good. What's up, brother?
So based on this topology. So if PC1 sends out a DHCP request, right?
Right. Which is what type of packet? A broadcast packet, right?
A broadcast packet. So that broadcast packet is being sent to, let's just say, if let's even go even further, if switch one had four links to switch two, that means that that broadcast of a DHCP request going through all four steps will be sent out through all four links to switch two to PC4, and that interaction, all four steps of discover, offer, request, acknowledgement, going back and forth through all four links throughout that process of PC1 getting that DHCP acknowledgement at the end. It'll go back. Wow. So that is, that's the reason why we should have a STP. I get to understand, because that'll create a broadcast storm.
So let's think about it, and I love your question, right? So let's think about it, right? So we're talking about the whole DHCP process, right? And I'm sticking with you and what Aaron brought up, right? Aaron brought up, okay, hey, my PC can't get a DHCP address, but it gets an EPIFA, right? And so we know that's 169, 190 or something like that, right? Whatever Microsoft assigns, right? And this is the EPIFA is Microsoft specific, right? And so, but that's not important right now, right? And so the DHCP, discover, right? It gets shot out, right? And so it gets sent out. And remember what I said, the switch, when Aaron switch, right, receives that unknown unicast, right? That broadcast message is going to say, hey, it's going to be unknown because I don't know the destination with the destination frame, destination address being all S. This means this is a broadcast, so I need to send it out all ports. So it's going to do its job. It's going to send it out all ports, right? But we expect, right, without spanning tree, we expect Nick's switch, which is switch 2, to do the same thing. It receives a destination for all S. It's going to send it out all ports. Okay, so all ports, right, being the ports back to the switch, but also the ports back to Of course, the Carolina Blue rectangle being maybe Aaron's and Nick's gateway for that building, right? And so it'll be sent out there as well, right? It's gonna get to the DHCP server, right? And Tuan, let's say you run the DHCP server, right? That's in the MDF of the entire campus. It's gonna get there, and it's gonna send it back. But then when it gets back, look at all the traffic that's still going through these two switches. Guess what we have, sir? A loop.
Ouch.
Nick and Aaron's switch is playing monkey in the middle or hot potato.
That's right.
I don't want it, you want it. You don't want it, I want it. I want it, you want it. They're gonna keep doing that, right? And so, Tuan, from your server, right? Whenever it tries to get it sent back, it's like, dude, I don't even know where to send this. I'm lost, you know? And so this continuous loop happens, right? And of course, these network devices are damn near PCs. And of course, we've been working in tech for a while, right? We know about CPU usage. We know about memory. We know when those things get high, a computer or a computer device gets, you're unable to function with, interact with it. It's, it doesn't function well. And ultimately it just stops working, right? And that's what one of the things that a broadcast storm or a spanning tree loop will do. It'll use up all the resources and say, oh, I got to shut down, right? And so Aaron and Nick's switch now has shut down until one of them unplugs a cable.
Correct.
Right?
Yeah.
Until we unplug a cable, right? But then if we unplug a cable, where's my eraser? If we unplug a cable, right?
That means you're out in the ether until you reconnect or you go out to grab another network.
Not just that, right? So if we unplug that cable, you guys do that to take care of the broadcast storm and get you guys users working. They'll start working, but we still have a single point of failure.
Yes.
So if you guys are taking off, you guys are in Cancun, right? With your significant other, link goes down. What happens? Guess where you guys are flying back to? In the middle of Cancun doing a limbo. You're coming back to campus to plug another cable.
Yikes.
Does that make sense?
Yeah.
Yeah, it does.
Yes, it does.
Does
Yes.
that make sense? And so, and again, we're not getting the CLI tonight. This is, Tuan, you know my talks. I like to talk theory as if we're having coffee chat and we're talking over whiskey and coffee, at the bar, right? So, I want this to make sense, right? And so the thing that Spanning Tree does, right? And we'll talk about the calculations later, right? Let me erase all these things. Right?
Yes.
Yeah. And let's re-annotate, right? So let's say, right, in Aaron and Nick's building, right? Because this is the building you guys are in charge of, right? So you guys have, two links plugged up between two switches, right? They're connected, right? And so Spanning Tree is implemented, you guys implemented it. And so what does this mean? Spanning Tree performs, some type of formula to go ahead and say, hey, I'm going to go ahead and go through a series of elections. And again, we'll talk about the elections in the next session that we have or what have you, because again, we're going to take Spanning Tree slow and a lot of these theories take some time. We're going to go ahead and say, hey, I meet a certain criteria. I'm going to go ahead and forward traffic on this link, right? And so this is between a series of, frames that are sent between Aaron switch and Nick switch, right? And so we're going to say, hey, Nick switch is going to say, hey, I'm going to send traffic that way, right? Through this port. Aaron switch is going to say, oh, I'm also going to send traffic down this port. But then Spanning Tree is going to say, slow your roll, buddy. You can still have this plugged in. So we're going to go ahead and within the software say, we're going to block traffic from coming in on this port, right?
Yes.
Because
Right.
what does that what does that do? What does that do? Let's go ahead and bring in the gateway. Oops, wrong color. Go ahead and delete that. Oops. Right. And so if we go ahead and do that, right? And so that traffic flow we expect, right? Going to go this way, right? We're going to, our PC3, Aaron's PC end user that he's trying to troubleshoot, they are trying to look at the DHCP server, right? The switch one is going to go ahead and get that broadcast, which is, of course, the DHCP discover is that destination frame is going to be all F. Right? It's going to send that out, right? Switch one is going to say, I'm going to send it out on my ports. I'm going to send it gigabit 0/1. I'm going to send it on gigabit /0/0. Mm-hmm. So whenever, let's talk about gigabit 0/1. When it blasted out there, right? Between Aaron and Nick's switch, they agreed, hey, you can go ahead and, Aaron, your switch, right? Your switch is the top dog switch, which of course this would never happen. Well, this will, I'm sorry. But based on configuration, this shouldn't happen, right? But for theory purposes, Aaron's switch is the quote unquote king switch, or the root switch, as they say, right? So he can forward frames down both of his ports, right? So he's going to say, hey, I'm going to go ahead and shoot this broadcast frame down gigabit 0/1. But with Nick's switch, is going to say, sorry, we're blocking frames from coming into this port. Sorry, buddy, we're not forwarding, nor are we, getting any packets in. Sorry. So it's going to go ahead and drop it, right? Switch 2 in the software is going to drop it, right? But gigabit 0/0, it's also going to, send out that broadcast on its port, right? And so switch 2 is going to say, oh, cool, I'm going to also send it out that port as well. And so what do we have here, right? We have one flow, right? We have one flow of traffic.
Yes, sir.
We don't have traffic going from switch 1, PC3 to switch 1 to switch 2 to switch 1 to back to PC3 and maybe to PC4, because again, it's unknown. It's going to go through both of its ports, and it's also going to get to the gateway. So it's going all over the place within a loop, right? And so the spanning tree resolved this issue. We don't have a loop. We have one flow of traffic.
Yeah.
There you go.
Does that make sense?
That makes sense.
Yes, it
Any
does.
questions?
Yes, it does.
Any questions?
No, I don't have any questions right now.
No, not right now.
All right. Cool. Well, we're going to stop it here because I don't like to overload people. I want you guys to take this in. Again, I'm going to make this a short session because I think Twan knows from our last Spanning Tree series, it gets real. But this time I'm going to go ahead and slow it down. So we're going to talk in baby steps, and then maybe we'll have a fun topology at the end of this. So it depends on which superhero symbol I feel like having.
Oh boy.
So. I'm grateful for you, Dave.
Say it again.
I'm grateful for you.
Oh, my pleasure. My pleasure. I'm grateful for you guys. I appreciate the opportunity. Well, on that note, folks, I'll go ahead and close the session.
Yes, sir.
It'll be on YouTube shortly. And again, if you guys have any questions, go ahead and ping me. Please study some of the, whenever you guys have a moment. I know you guys are juggling the entire world, but, please study, read up on, some of the fundamentals of Spanning Tree, because we're going to go a little bit deeper. We're going to talk about the formula. We're going to talk about links. We're going to talk about, the different type of port roles, right?
Yes.
And the port types, okay?
Yes, sir.
So get ready.
Sounds good. All right.
All right, folks. Well, you guys have a great night.
Thanks,
Hey, my
David.
brother.
You too, D.
Bye.
Bye, guys.
All right.